Okay, so we're given a problem here, and just kind of looking at it, you're looking for an ordered pair solution that's integer, and I'm sorry, real number ordered pair solution xy for the given relationship. Looking at the relationship, it looks a little strange at first, but then if you clear the fraction by multiplying both sides by x squared plus y squared, you get something that looks like a rotated conic section, and it looks like it is going to be an ellipse. All right. So the thing about this one over here is it safe to do that? Well, if you did multiply both sides by x squared plus y squared, and then just set x and y to 0, you'd find out there's no such problem. So it's safe to do that because that's the only problem that I would see where x equals y equals 0. All right. And I went through a little blurb over here about the how to rotate a conic section, and it involves some trigonometry, and we did go through that. And then what I found out at the very end of it was that it was a degenerate conic section. And being a degenerate conic section, I realized that there's only one point to it. And we found the point. And this is the point we found over here, all right, for the rotated thing. And then we plugged it in to our rotation formula, and we got 7/3, 5/3 for the point. And I always just make a mistake somewhere. So I'm going to go to Sage. I got to open up Sage first of all. I'll launch my terminal and type Sage in. I'm running a pre-release version of Sage, so they give me a little warning up front. But anyway, reset. It's always a good thing to start with resetting when you start a new problem. X and Y are variables. And then I'm going to copy this equation in. All right. And now what I'm going to do, I'm going to solve the equation. Maybe I should go back over the actual problem. So let me just tell you what we just did over here. That's a long question, isn't it? But anyway, I typed in the equation, which is 8xy. You notice I'm using multiplication symbols. You have to. Plus 10x minus 2y minus 10 divided by x squared plus y squared, and that equals 5. The double equal sign is indicated in the equation. This is called an assignment operator. That equal sign is an assignment operator. So I solved the equation for a point, xy, and I'm going to display the point to you. And over here, I guess it looks rather strange, all right? Now, what I mean by strange, looking at it, I'm getting, looks like there's an infinite number of solutions to it, where you could select x equals r1, any r1 you want to choose, and then pop it into the y, and you'll get a solution for xy. And same thing, x2, r. You notice that you're looking at these things over here. There's certainly very similarities about these things here. So let's go back to the code. A little strange solution. You might be confused by that. Let's go back to our code and see why we did that. And I'm going to now, the function f of xy, that's right there. And this is an assignment. And the assignment is I'm taking, maybe I didn't copy it all the way. Let me just take a look at it. No, I did. All right. And then what I'm going to do is f of the solution that I found, which is 7/3. I'm just checking 5/3. And what should that produce? It should produce the number 5. It produces 5 as expected. Now, of course, what I want to do is over here is I'm going to do what's called a Boolean. And the Boolean is I'm saying, is 5 the same thing as evaluating the function where the solutions have been found? And I want to claim again what S0 is. S0 is this thing over here, right? And this is S1, all right? Now what do I want? I want the first element of S0, which is this thing over here. Oops, sorry. But I want the right-hand side of it. And then I want to take the left-hand side, the right-hand side of the second one. So that's going to be S01, right-hand side. And this should be true. It's true. Now let's just use the up arrow because I want to retype it, and this often I'll do this a lot, up arrow. And I want the second element, all right? And that's going to be S1 now. Let me go back with my cursor. I'm going to change this to 1 and change this to 1. Pretty easy to do, not to retype everything. And it's true again, all right? So what are we verifying? That the solution that Sage has given us, although it looks strange, does produce a true statement. Now, one may wonder, how do you get the 7/3 and the 5/3? What you got to do is you got to select an R that would eliminate the I in the problem because they want a real number solution, right? So you got to find an R that eliminates that. Now, again, I don't know if I did that. Let me just go to the next page. Yeah, I did it over here. I selected the values that make the I disappear. And that's really not that bad to do, all right? So that pretty much completes that problem out. It's a difficult problem. At least I believe it's a difficult problem, especially rotating it. Certainly, there are other ways to do it. Of course, there are. Rotation is something that's taught typically in a pre-calculus course. Thank you.